uh, corresponding to a particular loading, the magnitude of the deformation will be extremely low. So it's very hard to actually understand whether the structure is deformed or not. So for example, if you have a 1 meter long beam and your deformation is just 1 millimeter, it's going to be extremely difficult to understand visually if there is a sufficient deformation. So you can specify a scale factor, and depending upon the scale factor you provide, it's basically multiplying your deformation with a particular value, and that just pops up on the screen. So the deformation is not changing, it's just your visualization of the deformation is changing. So you have a set of other commands over here. So maybe when Gianfranco explains it, he might explain it in a bit more detail. So that was how you can visualize the deformed mesh. And another thing that you can see is the diagrams. Now, if you actually go to the PDF over here, so you can actually see that these are some of the results that you're getting. So this is the moment diagram, MZ moment diagram, and you should get a maximum over here and a minimum at the tip. And you have the shear force diagram, which should ideally be a constant all over the beam. So we can compare these results with what Luzas is telling us. And so you can go over here, right click on that, go to diagrams, and inside the properties window, you can choose the kind of diagram that you want to plot. So right now we are going to choose force or the moment, and once you click on that, you have various components. So there's fx, mz, fy, and cd. I'm not entirely sure what a cd is, but fx basically deals with the component of force along the axis of the beam, and mz, so z is the axis which is out of plane. So mz refers to the bending moment across the beam. Fy is the transverse, because y is the vertical axis, so Fy will refer to the transverse, vertical force or the transverse force. So if you want, you can plot Fx. So immediately you'll see that an orange thing or an orange line pops up with certain values and stuff like that. So basically, orange is the color assigned to the diagrams, to the prospecting results. So because in our current problem, there's only one transverse force being applied, there's no Fx, there's no force along the axis of the beam. That's why it's 0. But if you go and click on Fy, you should get a certain result. So right now, you are telling you the results are telling you that there is a constant shear force across the entire length of the beam, and it makes sense. So if you go back to your results again, this is what you're going to get. So the value of f in the problem was, I think, 400, if I'm not mistaken. So the value of shear force is minus 400, and it's a constant along the length of the beam, and that is exactly what you are going to get over here. And the other thing that you can check out is mz is the value of bending moment, and that again corresponds quite well with the results that you see. So it's a maximum at the root of the beam, and it's 0 at the tip. And if you again go back to the PDF, you can see that it corresponds quite well. So you'll see that the maximum magnitude is F into L. So L is 1 over here, F is 400. So the maximum is 400 into 1, which is 400. And that is exactly what Luzas is telling you.
Is the camera up? You can even you can show also the reactions. Do you remember?
Give me a moment. I'll just come back right now.
I'm coming back from Arinto's PC. Okay. Okay, webcam is turned off, but it's fine. Okay. Okay, here you have seen the internal forces. We can also discuss. You can also check the values of the external reactions, that in this case are simply vertical reaction and moment reaction at A. The horizontal one will be 0, the horizontal force will be 0. So here, if you click the right button in the mouse, here you okay, you can select values. You can leave diagrams on, or you can turn it off. You can turn off even from the left window here, diagrams on, off, okay, on, off if you want, but anyhow, we can turn it off. You can select values, so please click on values. As entity, please select reaction. Is the last one. Reaction component. RSLT is a resultant, so we are not interested in the resultant, but click and select the component. For example, Fx, the horizontal one, will be 0. Fy, vertical component or reaction, and Mz. Mz is the moment. For example, Fx, we see that T0, I double click here, Fy, let's see, Fy here is 400. As you can see in vertical direction, here if you don't want to see the green reactions at the beginning, you can go left on layers, geometry, I'm wrong, it is not here, is on attributes, sorry, so layers on the left, attributes, support, and deselect, so I click none, for example, okay, so they disappeared, and only the value of reaction that you selected is visible. So Fy is 400, positive, so upwards, Fx is 0, as expected, 0, and Mz is 400, positive, so counterclockwise, positive. Okay, we can have a look at the deformed mesh again. So I deselect values here, so off. Diagrams can stay off. I, from attributes, put supports all visible again. Okay, so here deformed mesh. Please click